demonstrating for part 1. So here we can see this is a schematic diagram, and then now this is a circuit for it. Now this one, the blue one, is the D switch, and then I'm using the red one, the switch, as a clock to demonstrate to you this part. So first of all, D is high, so I'm going to turn D to high, but A doesn't light up, so this is the expected output. Now when the clock is on, A lights up, and then after that, after some time, D is back to low, but A remains lighted. Now from here, the clock is on for an instant only, and so we can see that A turns off. And then now we look at this part, D is light up again, only for an instant, but now there's no change of A. Now for an instant again, A is lighted up. For an instant again, D is on. And then while D is on for this short period of time here, there's no change. But when the clock is on, then A lights up again. Okay.
My name is Aaron, and this is the schematic diagram for this circuit. As you can see, the clock is set to 500 kHz. And now to the schematic diagram. As you can see in the schematic diagram, the Q bar is connected to D, whereas the Q is the output. Okay, now we move on to the graph. And as you can see, channel 1 is around 500 kHz, whereas the channel 2 is around 250 kHz.
So I'm demonstrating part 3 for our lab, and part 3 is a 4-bit synchronous counter, and so that it counts from 1 to 6. So this is a CAN map for the reload logic, so that it counts from 1 to 6. And we can see here, this one is the circuit design. And now we proceed to the circuit. Before it's on, the counter is already 1. So once I turn it on, okay, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So it counts from 1 to 6. And then the question asks whether the circuit stopped correctly at 6 when the run stop button is low. So we wait for 6. So yes, it does stop at 6 when the run stop button is low. And then now the question also requires us to produce a random number covering the full range of 1 to 6. So in order to produce a random number, we increase the frequency of the clock. And then now we try again. So this one is 1, and then this one is 5, and then this one is 1, 5, 6, 5, 2, and 6. And then this one is 5 again. So we can see that it's actually producing random numbers depending on, it depends on the frequency, and it depends on how long you press the round stop button as well. Yeah, so this one is 4. And now that's it.
My name is Aaron. So as you can see in the part 4 of our lab, we are using 3 binary numbers to create 4 inputs into the die module. So move on to the CAN maps. All these following CAN maps, we are using it to create the combinational circuit, which is shown here. Okay. Moving on to this circuit design. Okay, so I will start off with 1, 2, 3, 4, 5, and lastly we have 6. Okay. My name is Aaron, and now I'm doing the part 5. And in part 5, we are combining the circuits of part 3 and part 4 to produce an electronic die. So we move on to the circuit. So 1, 2, 3, 4, 5, 6. Okay, so you continue 1, 2, 3, 4, 5, 6. Okay, so this is the original sequence. So after that, I increase the frequency to okay. So
For this
I after I increase the frequency to 2 kilohertz, it will produce a random number on the die display. So start off by pressing. So now 4, 3, 4, 3, 1, 3, 1, 2, 3, 6. Okay, so as you can see, these are all random numbers.